Yeah, but for Jackie, you need to think about what kind of thing you try to visualization. We still need to elaborate the idea. Oh, by the way, that the Professor Shao, she has a database, right?
Yes.
And what kind of database?
It's on myocardial infarction.
On myocardial infarction. Okay.
CVD.
Does that contain that the transaction is already sorted? Every patient they have one record or have multiple record?
I was thinking for another data set.
I think that's fine because last time we said that we can try to retrieve data like cough, some small disease, some acute disease, some chronic one. Yeah, we can download different kind of. Yeah, so I think that part is okay. Yeah, that part will be manageable. Okay, so I promise that I will give you a tutorial how the database looks like. Yeah, I try to turn down. No, not turn down. I mean, I don't want the presenter view of my computer, but it's always show the presenter. Okay, good. Okay. For you, it's better to read it the English part. The main here is for this column. That's mean the hospital ID. I mean, so in NHRDB, you can know from which you can differentiate which hospital, but they won't let you know. But you still can guessing. For example, if there is one hospital, they have many patients, and they provide the zip code from Taoyuan. Basically, that is mean Chang'an. Okay, so we still can guessing up for NHRDB, it won't. The design is they won't allow you to know who are the patient and who from which hospital, because it's not very ethical that you can analyze the data from based on know from which hospital. But actually, we can do that. So basically, we know the data from which hospital, and they provide a zip code. So previously, I did a research project that is I can make a disease map. So basically, if you are interested, you still can do that kind of project. You can, for example, you know the patient from which area, so you can use the circle, big circle, and a small circle and a bigger circle, then to reflect the frequency of disease. So you always can cooperate with the something we call the GIS, the geometry, yeah, information system to do the visualization, and especially for those infectious disease, people they are interested about whether we can use those GIS information to predict whether the disease will propagate to other area. For that prediction is kind of also a hard area, but it's interest but not very academic useful. For example, like the last or 2 years ago, the MERS, the respiratory acute disease from Korea, originally from Arabic Saudi United Kingdom. They have a lot of prediction model to say, oh, how quick they will spread to all over the world. But in fact, no. Yeah, but that is kind of thing you can do. So you have the hospital ID, then also we have all the doctors data. So each data set, you also know their who claim that. So basically, we have this. But usually, when we doing the research, we didn't including this part. So far, I know in my data set that we didn't include this for research. Usually, we don't analyze the behavior between the doctor, because I'm not sure whether the Department of Health they have concern about that. If you want to apply that data, maybe it's by case. I mean, it's by application. I mean, even sometimes you say you want it, but they still don't give you. We have, I mean, the DOH have that data, but probably you cannot download that. So we have the doctor. Then here we have two main parts. Here is for the OPD, and this is for the IPD. OPD is mean they are the visit daily, then and the inpatient, that's mean who the patient stay in the hospital. So, and the next part is the keyword. The key part is for each. For the OPD, they will provide two different data. They have two tables. So each time for each visit, they will have we have table 1 and table 2. Table 1, they list the basically is the visit information. For example, when and your ICD, your disease code, and some basic information. For those drug information, they are in different table. So basically, if one patient for example, this is OPD table, and this is OPD TE. Okay, and this guy, ID1, they visit, for example, this day, and their ICD, for example, cough or something. Then this guy was prescribed 5 drugs. Then here for this OPD table, they only have one record here. But for the OPD TE, here they will say, oh, ID 1, blah, 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 and the drop 1, drop 2, drop 3, and drop 5. So if this guy, this visit, they have 5 different drops, so they will have 5 records in the OPD TE table. So in this case, if you want to have this guy, the whole record for each visit, then you will need to join the table. Join this table. But actually, because this ID1, they can visit several times. Okay, so we cannot only use ID for join. So in this case, they need to use the 6 record for join. Oh. Okay, so you got the idea. Is they have 2 tables. Did you? I'm not sure whether you have a class for introduction for the database. In this case, is to reduce the table size, because that basic information. For example, they have 5 drug. If you have all the same thing repeat 5 times, the database will become so big. So the idea is for those information are redundant, then they will separate into a table. For example, if you visit this hospital, each time we don't document every your information. We won't write down your birthday, your gender, or your address all the time, because I just need to record your ID. That's enough. Then each time I only need to know who you are. Then if I need the information about your birthday and whatever, then I just need to go to link another table. And it's not necessary that each time when you visit hospital, then I put everything again in the database. So that's the idea of that. So you will know we have for the OPD, we have OPT and OPT-TE. Okay, so I'm not sure the full name for TE, but the idea for TE is, I mean, for those procedure drug, if you so in the future, if you need to query the drug information or some procedure like operation and whatever, you need to go to check on OPT. So the same thing for admission is the same. They have the IPD and IPD-TE. So each visit, each stay in the hospital, the IPD, they list some basic information about the visit. And for those procedure, operation, procedure, laboratory exam, and the drug prescribing, they all from the IPD-TE. So each time, so basically, if you are retrieving data from the OPD and IPD, so you need to deal with these two data sets. Then because the OPD is the size is far more bigger than the IPD one. So usually, sometimes when we just do some preliminary trial, so you can check on the IPD one. Okay, so basically that's the two main part. One is the OPD and IPD, and each one they have the basic table and also some detailed table for including the drug information and the procedure information. Then here we also have we call a catastrophe registry. Basically, is for those, I mean, catastrophe. That means some severe disease like the uremia and some cancer. They are all belong to catastrophic disease because in Taiwan for our health insurance, if one guy they have a severe disease which are listed in the catastrophic registry, there some medical expense can be waived in the hospital. 重大伤病就可以免部分负担了。But this is very useful because sometimes we argue the ICD from the IPD table or OPD table is not accurate. But for this catastrophic registry, that is very accurate because it's require you to bring the pathology report and all the necessary document to apply this card. So it's kind of very strict process. So if sometime if you're I remember one of my students, they are doing the head and neck cancer, so they utilize this catastrophic table. That will be very useful. That. Okay, so that's the whole idea about that. And but actually here there's another table we didn't include is actually we also have I think we call the mortality table. So basically we but for normal NHIRDB they didn't provide the death record. So but in my data set we are able to know a patient they die or not, so we can calculate survival. But sometimes actually officially we cannot use that data set right now. So if you need to if you want to do the research, you need to get familiar with the OPD and OPDTE and the IPD and IPDTE. And also, I think we don't go through the detail of each column, but we have we have the code book. They have a very detailed description about what's the meaning of each table. Okay. So any question about the NHIRDB structure? So basically, if you want to query any disease, drug, procedure, you just need to check this for data set. So we have a script. So it's allow you that if you want to query one disease, they will query the both table and integrate become a one table. That will save you lots of time. That you don't need to do the query on two table. Okay, so but it takes a couple months to practice, then you will be able to do that. So, but I won't expect you that you can do this in one semester because that will drain you all of your energy. Then, yeah, it's not worthy. We spend too much time on this. So, I decided to just give you the introduction that you have the idea, but for the practical part, I won't. We don't limit to. I mean, to complete that in this semester. Okay.
上面的那个数字就是上面的档案会记载的东西，
你说
是那个绿色的字。
No, 这个是 table name. I said that from this table you need to look up from this. So you need to use this four table to because you, for example, you cannot use the patient ID because that person can visit several times. So we will need include the date and the hospital ID. For example, that guy can visit two hospitals at the same time, in the same day. So you also need a hospital ID to differentiate. And for example, even for the same hospital, they will visit different department. For example, in the morning they visit the cardiologist, and in the afternoon they visit whatever. So they need 6 information to differentiate each visit. Okay, so if you want to find this guy, today their specific order from the drug, you will need to provide the 6 color information. Basically, you can see the hospital ID and the type and the applied date and the case type and sequence number. And so for those information that can guarantee you can find a specific visit and get the information. Okay, but we already solved that in the database level. So basically, you don't need to know this detail. I mean, you just need to type. For example, you want to switch to different ICD, then you just replace the SQL language in the ICD. Then the SQL, we already solved this in the SQL language. So that's we decided to take advantage of the SQL language. The SQL language can help us to avoid this kind of the complex. Okay. Anyway, but just give you the idea about how this work. So, but for the practically that actually for query disease, for query drug, actually you don't need to deal with this complexity. We already solved this. Okay. Okay, so okay, I decided to give you another big project about the laboratory coding system for how we use a vocabulary, how we use a standardized vocabulary to do the disease surveillance system, and let you know how the vocabulary can help. Why I cannot move up and down? Mhm. Okay, my PowerPoint just cannot up and down, but we just use this. So actually, the idea of this project is kind of very straightforward, because you can imagine that the CDC, they have a great interest is if they can know what kind of disease happening in each hospital, they can monitor it in real time, then they can do the disease surveillance. And that would be very useful that, for example, that if we know in the winter, we have lots of influenza, the cold, the and also like in summertime, the dengue fever, because in Taiwan, so for those disease control, that we know how the disease progress in different hospital. That is very important. So the CDC, they already developed this for more than 10 years. They did many pilot project. They just want to collect the data from the different hospital. In order to do so, they are thinking, because in each hospital they have different laboratory name and disease name, so they think they want to use LOINC to for reporting the laboratory data. But before I start working with them, they have at least 3 or 4 different research projects, but all fail. And the problem is, later we will explain why they fail. But that is, we can use the same story is, before this laboratory monitor system, they have another project is, they want to monitor the ICD of the ER patient. So imagine if, because for example, in this rural area, if they have some patient, they have the influenza or whatever, they will send to our hospital. So in the ER, they will give the diagnosis or give the ICD to the patient. So if the same idea is, if the CDC, they can know the ICD distribution from each hospital, then they will be able, they have the ability to monitor the disease prevalence rate across nationwide real time. But again, the project also failed. Then you will ask why the idea, because yeah, we the why we fail, I mean, is the infrastructure? No, because right now we all have the internet, and you should know that our government, they spend lots of money. We have I forgot the full name, but it's kind of like a national health infrastructure network. Each hospital, they have a specialized internet connect to the Department of Health, and they have the gateway. So basically, the hospital, if they want to send data to the government, we already have that infrastructure. They are confidential. They are all encrypted. So there is no, there's no safety concern that because we already have that infrastructure. Then you will ask, since we already have all the information, then why we still fail? So the key point is the semantic interoperability. Because if you, I'm not sure whether you have the experience about typing the ICD-9. So basically, I have the experience that I think I am one of top, maybe top 100 or maybe something like that, who have the experience about the ICD and the clinical practice. I think because I received both training, and I'm actually using these two information. But honestly, because sometimes I need to go to the ER and need to see patient, and sometimes I need to do the ICD. Actually, for myself, I still having problem. For example, sometimes people, they have the low back pain. They say, "Oh, I have the back pain." That is quite common. It happens all the time, especially for the old people, old lady. They visit hospital, they will complain have low back pain. Then I need to documents in using the ICD to say I need to assign a disease code for that. Actually, I don't know which ICD code is exactly for that. Then I checked. Then suddenly I found a term. Previously, I didn't quite use often. Is lumbago. Yeah, actually, when it's not a, I don't know. Even in my lumbago. Yeah. Yeah, lumbago. So if if I type low back pain, actually I cannot find exactly the ICD-9. But if I use the lumbago to find, then I can find it. So that's the problem is even you know some concept, but they have too many names. In this case, we call synonym. Synonym is mean 同义字啊。they have different they have the different for the same thing, but they have different name. But sometimes is they have slightly meaning difference. But yeah, so but I think the terminology class we are discussing this, and like I previously I give you the idea is about the drug for antibiotics. For you can have a more general concept name, or you have more specific name. So why that project failed? The project they try to monitor the ICD of the ER patient to monitor disease fail is because they have too many ways to coding for disease. Even for the cough, even for the influenza, they have tons of code to deal with that. So basically, yeah. So that's the reality is we ask people to use the standardized terminology like ICD-9 to coding, but in reality is those code just too complicated. Later I will cover why. Then basically you need some framework to deal with this kind of thing. So after I come back to I graduated, then I come back. Then the CDC, one of my junior who is also graduate, I mean, is your senior who he is a doctor. He graduated from GIMI. Then he currently work in the CDC. They know I'm the expert of the LOIC. Then they invite me to give a talk about my PhD work, and we have some conversation. Basically, like I said, that they already have more than 10 years experience about. They try to use the LOIC. LOIC is a coding for laboratory. They try to use the LOIC to report disease. Then they ask me lots of questions. So basically, I already explored that in my PhD work. So I have some suggestion for them. Then they agreed that probably can solve their problem. So, but okay. So basically, we just we try to use the LOIC to submit. For example, Shuanghe is part of one of the participants. So the CDC, they have ambitious, at least 20 infectious disease like Salmonella and like TB. Yeah, that's kind of infectious disease which government they care about. That there at least 20 disease for those laboratory tests is related to this 20 kind of disease, they are required. There is a law. They are required. Each hospital they have they need to submit to the government. So, but before that is a manual process, and right now is we hope we can do that in the automatic fashion. So we start from 2014. Then actually they provide many money for that. In the first year, we include 20 hospitals, and each hospital we give them 1.5 million NT dollar to helping them to whatever you to developing the system, try to develop a report system to connect their laboratory system to the government hospital. So here is the a visualization is here the orange one is the hospital one, and the green one is the CDC. We hope the hospital data we can use a standardized terminology, for example, LOINC, to submit to the CDC. Then they can use the LOINC to do the statistic. That's the idea. So here's the electronic, the English one. So you can see the list. That's the acronym for Laboratory Information System. So basically, in each hospital, I mean, for all the major hospitals, all the laboratory information are stored in the list information. So we will use the LOINC to submit to the CDC. In this case, we call the electronic laboratory reporting system. Okay. Then here is our research structure. From the left-hand side, here is we show basically we will propagate the data from hospital laboratory information system. Then we will create a vocabulary interface. In here, we will translate all the information to LOINC. Then we will utilize some existing gateway and submit data to CDC. So here you can see that in each hospital, in this case, that is a stool culture for Campylobacter. I think that, yeah, that is kind of bacteria. And the hospital B, they have actually the same thing, but they have different names. So you can imagine that if they all submit this to CDC, then they will drive them crazy because they need to know the detail. But you can imagine sometimes this, for example, the CDC is the IT guy who in charge of this. They have no idea about the laboratory information. But honestly, even myself, I'm a clinician. Sometimes some laboratory information is just too complicated for me. Even me, even the staff from laboratory, sometimes they still need to have some conversation, discussion. Then we will decide which are the correct information. I mean, for the mapping. So the idea is here for each hospital, they have different name for the same thing. Then we hope, in this case, we expecting them, we wish they can use the standardized LOINC code. In this case, this is the LOINC code for stool culture for this bacteria. So if each hospital, they can map their laboratory item into a standardized LOINC, then for the CDC, they just need to look at the standardized code. Then they can avoid this kind of complicated. So in this case, here is an example. here is we use the HL7 message. So we use the HL7 message to is a way a syntax a syntax syntax standard then submit to LOINC. Oh, sometimes if you have a class introduction for the medical information, sometimes they will give you a set question, ask you about what is about interoperability. Here is the perfect example is here, this is the semantic interoperability, and this is the syntax interoperability. You can imagine that, for example, here we have, for example, if we want to pass this information, but if we put the number here in the last, then for human, we can understand the meaning. But for computer, if the data structure, the data structure is different, then that would be a problem. So in this case, this is we call the message syntax, and this is semantic. So if we hope we can reach the interoperability, so basically in hospital or in the informatics, we need the semantic interoperability, also the syntax interoperability. Okay, that's also my when I do the oral qualification, my boss asked me about that. Yeah, can you elaborate what's the two basic requirements for the interoperability? So one is the semantic, one is the syntax.
So semantic is for vocabulary.
What?
Semantic
is for
vocabulary.
Yes, yes. Yeah, like for example, I can send you information through email or text message, whatever. Then that's fine. But I can scan document, or I can send you a PDF. So in that case, we can exchange data, but the scanned document is a graph, is a picture. So in that case, it's not a semantic computer understandable. So in that case, is we only reach the syntax interoperability. We can send information, digitize information through email, but we cannot. A computer cannot understand the semantic. So in this case, for the CDC, if they want to collect data from hospital for real-time disease monitoring, they need these two things. But I think the first one is easy. You can just force people to do use the HL7 to send data. Then the most difficult part is LOINC. I think because you don't have the experience following, then you will feel strange. You will feel strange that you only have 20 disease, then just all map into LOINC. Then that's very simple. Why you don't see what's the complicated part? But let me give you some number, then you will know that's what complicated. Originally, they think, oh yeah, just use LOINC. 20 disease, it's not a big deal. Then they at their pilot stage, they try to manually curate all the code is related to this 20 disease. Can you have a guess how many LOINC code they need to deal with for this 20 disease? I mean, how many LOINC code is related to the 20 disease? Can you make a guess? 500, 1,000, 5,000, 10,000, 20 disease.
Plus.
Pretty close. It's 6,000. So, but you can imagine because they have many, because you can from stool, you can from urine, you can, but sorry, I could, in this case mostly from stool, but just they have many different variation. So people, they just have a problem that they know this, they are they are doing this exam, but they don't know how to choose the same loin. Okay, and I said that they all the CDC tried to do that for more than 10 years. Then they asked some 3-4 hospital to do the pilot project. The problem is they all use loin to do that. They did the mapping, but they have some slightly different between the hospital, and they don't solve it. Then, so basically, because when I was in US, we know that due to the code design and some practical issue, actually it is true that the same thing, they have more than one loin code is okay for reporting. So first we need to admit that due to some issue, the loin code design, sometimes they just 2 loin code is all eligible for mapping. So in that case, basically it's easy. We just need to set up some committee to harmonize this. So actually, what we did for this, we have a big improvement for this project is we set up many expert meeting for solving the problem. Even we also send out our question to United States. I talked with my boss, Stan Hub. Sometimes, then they will give me feedback. And actually, we discovered some significant issue that later I would say that actually the Taiwan experience, we provide some very good response to loin committee because we reflect some regional issue. Actually, not regional, it's a kind of international issue, but they don't think about that. So actually, they put that in the latest loin version. They made up some change that due to our contribution. So basically, someone join.
Oh, I just.
Are you okay?
Just testing.
Oh, okay. Okay, so that's the app, but we don't have this architecture at the beginning. Again, this I want to give you the idea is only you did lots of things, then you can conclude something like this. Okay, that's some we don't have a very clear mind or design about this research design. But after we already complete the project, then we come out this slide. But the same, in the future, if you're writing your paper, then you will need to provide this kind of figure. That will help you to do the logical thinking. Yeah, you can think this. For this is the real data. Then here we will do some explanation, and here we show you the interaction between the entity. Yeah, so that's people. Then that make people easily understand how you propagate the information.
So, Professor, only these are visible, and up to loinic is invisible for the users. LIS.
You can say that, yeah.
Only the administrator or the lead physician can see
Yes,
everything.
yes. Yeah. In this case, you only can submit to CDC. You cannot go back to check the data. But the CDC so far they say that they don't 会关灯，待会我会关，
你们回去会走大门还是走医师办公室？
就走这个门了。
哦，就走大门。
对对对。
太麻烦，对吧？
好，没问题，我
这
讲。
间教室。
好 ，OK， 好 ，OK。But they promised they are going to share the data for those statistics. I mean, because they think each hospital they work pretty hard to provide data, but they say that they are thinking that they will also share if for example, if they have some disease outbreak from other hospital, the CDC they are willing to also share the data to each hospital. Yeah, imagine like for the drug right now, actually in Taiwan, I think that is also a very successful project is that 云端药力 we have some pharma cloud that all the drug information. I mean, even this patient, he yesterday visited some hospital. I can know what kind of drug he was given. Yeah. So that here is the idea is I think we already have the class. We tell you how to for example, this the Campylobacter species, this stool culture, and this is for the virus. So in the pilot project, that is also a good methodology. We think that is very helpful. Is we in the first year project we also include we do a parallel project. We including 3 hospitals for the pilot project. The idea is we think some common problem, if they happen in these 3 hospitals, we guess 80% they will have, I mean, other hospitals will have the same problem. So if we collect the data, we gather experience from a small group, then we can, because for the small group, we can easily communicate with the mapping staff. Then we can easily share the idea. Compare you talk to 20 hospitals, 3 hospitals, that would be more easy. So that is kind of success that we work very closely with 2 other hospitals. We explore many problems about the existing. For example, there is a common test for the pregnant woman when they deliver the baby, because they will easily be contaminated by the streptococcus or something. Then there is a routine test for that. Then actually they have 2 loin code can report that. But actually for that purpose, the loin committee, they create a loin code. They just say streptococcus for the pregnant woman or something like that. So after we have a small meeting to discuss which code is suitable for that, then when we have a globe meeting for all other hospitals, then we just tell them this truth. You just for some specific test, you just use the specialized login code. So in that case is we use the 2080 approach. We believe 80% of the 80% of the common problem that were happening in all hospitals. So we collect the experience from 3 hospitals. Then we actually it saved us lots of time. So basically, here is the most important diagram that on the top, sorry, this Chinese. On the top, that is the CDC, and here is the hospital, and here is the expert. In the past, we only have these 2 rows. We have CDC, we act, and the hospital here. We ask hospital to use LOINC to report to CDC. We did a lot in the past 10 years. We asked hospital to do a LOINC mapping and send it to CDC. Then actually the perfect result is the same thing. They all use the same LOINC code and to send to CDC. But the truth, it is not that the same thing always use the LOINC. Then we need the evaluation. So we have some expert committee. I'm one of the committee here is so the hospital when they do the LOINC mapping, then we will evaluate. So after we they have some common problem, then we will try to decide which is the best way. Then we will produce a guideline and send it to CDC. So basically, we used 3 years to accomplish this project. So only the first year we have many questions, generally, because for the first year, everyone, they don't have the experience. We have lots of questions. We need to talk to the LOINC committee in the US. Then, but after finish of the first year, we already collect almost like 300 questions or something. Then we can produce a guideline and use that for the second year project. So basically, after we make that guideline and send it to for the second year's hospital, actually they are pretty. You can imagine at the first year for the first 20 hospital, the question is like this. But after we add in more another 20 hospital, then the difficulty or the question increase will become very small. You got the idea? Because the first year we include 20 hospital, so maybe they have the 100 question. Then the second year, then we will have another 20 hospital. But you can imagine, maybe the first year question, they have 80%, they are overlap. So they maybe only have 10 new questions. So each time we accumulate more experience then for the third year, so far according to my memory that actually we don't have too many new things. I mean, then we just
Mostly covered.
yeah, almost we cover that. Yeah, I think that is a very actually it's simple and it's not big deal, but it worked.
Long time
Yeah, so but you can imagine the 10 years they repeatedly doing this again and again. There are some different professor, the Yang TMU, they all did this project before, but they just using a different tool and the different people they group do the knowing mapping, but they just we say it's just too radiate, not it's just generate too many questions, but nobody try to condense it and try to provide a guideline to solve it. So that's our approach is that we try to do the modulate. So yeah, it's also again. I think for Jack's group, we just submit a big project to TMU that they try to do the learning hospital. One of mission is try to increase the ICD coding because we all know that the ICD mapping, the use of ICD is kind of complicated in Taiwan because everyone they just use the different way. So yeah, if you are interested about this, I think that project is it's held by it's run by Jack, but yeah, I should tell him actually I'm the expert to do that. Yeah, so if you are interested about the ICD mapping, actually we that is some worth it. And I think that is can be commercialized because if you can actually Google are doing the same thing because behind the Google, because they know what you are typing, they truly understand you are typing, then they can provide you the
Summation.
yeah. The first level is they need to understand the meaning and the synonym. Yeah, they need to know the full name, acronym, and the different local name. Yeah, that is the first stage. Then, for example, if I type Porsche, okay, so then I have some typo of PORSH. Okay, they will understand some typo. Okay, is a PORSSCHE. Okay, the first level is they can deal with your typo and you can understand some other different, like you type in the Benz, and also if you type Mercedes, they all know they are Mercedes-Benz. The second level is they know your typing is about car. Then they will return you that information about the car. I think you all have the experience that because for me, I think the internet is kind of terrible. Do you have the experience that I do have the experience that I still don't know what it is. If you are searching something on Amazon or Google, then they will display the relative merchandise information everywhere. No matter you are browsing the internet or you go to the Facebook, they just display the information they want. For example, if I am searching some for example, okay, I'm searching some earphone on Amazon. Then I think they store all the information. Then when you are browsing the Facebook or search the Google or some the company's website, the AD, the advertisement, they just prompt you the relative information. But
Yes.
actually, that is very cool. That's really what we all talk about the medicine. We say the AI or something. That is a perfect example that that if the computer really know what kind of information you are interested, then yeah, because we always say that one of mission for the one of challenge of our current IT system is whether the computer can save you to doing the repeat thing. So that would be very cool that if I'm, for example, I'm typing the drug, then the system know I'm typing the drug. They just display the relative information then, and automatically that's quite related to your original thinking that if you are typing some, you are using a drug system. I just use some AI system to provide you the necessary, no matter provide the dosage or whatever information, and that is very useful. Then I think that was very charming.
And if we can make this a little bit more interesting and helpful.
Yeah, then we can do some brainstorming about that kind of thing, because sometimes if we want have some progress about medicine, you need to have that kind of imagination.
Yeah.
Then think about one thing we have just talked about the laboratory. Actually, for the laboratory, we have the problem that, for example, for the neurology, sometimes they have some rare disease. They are related to some autoimmune disease. Then we always have a problem that we don't know which laboratory is suitable for doing that kind of screening. So actually, that is a really discussion I have with the team of the laboratory department. They are trying to develop a system that if one doctor they want to do some test, currently is you need to know the exactly laboratory name, then you can prescribe, you can order the laboratory test. But actually, we can use the disease, we can query, we can by disease level. For example, I just type TB, then we all know that we have 4 or 5 different kind of panel for TB examination. So I just type TB, rule out TB, then they just give you all the necessary laboratory. Actually, I believe that is something that is very worth it for and can be commercialized.
Yeah, or commercialized for the serious aspect of AI.
And back to this, there are 2 things can be discussed is how you decided. I mean, you need to train your system to know, when you do some disease, then what kind of laboratory is related. There is 2 ways. One is you need to manually create a knowledge system. Okay, so you need to have a nice database. They say when you type TB or tuberculosis, then they have some of this. But that is not too fancy. You just manually do the typing thing. But the better way is using the big data approach. Is you can imagine that in the hospital, the reality is every year they have some doctor coming into the hospital. So at the beginning is the young doctor, they don't know how to do that. And but after they, if they don't want, they want to do something. For example, one of my junior, they want to do some lab test. At the beginning, they don't know what they do. They will ask me which test is. So basically, I will say, oh, when you have this diagnosis, then you do blah blah blah. So basically, if we can have a big data approach, is if we can record. Actually, we already have that data. We when this patient they have a diagnosis, for example, young stroke. Sometimes for the young patient they have stroke. Then we have a template of when we know this guy is young stroke. Then we will do a series of autoimmune tests. So basically, if we can, actually those information, they are all in the system. So if we can analyze the ICD and their following laboratory, then actually when the next time, for example, 10 people, for example, there's 10 patients. Each time this patient, when they was given this ICD, then they will be given a series of laboratory tests. Then if we can learn that from our daily system, then that will be very charming that our system just, I think, for example, the drug is similar. When we have some ICD, then, and also some physician base for this guy, because we always have some pattern. When like people, we have a pneumonia, okay, the best idea is when I type the progress note, I have I make a diagnosis, say, oh, this guy have a pneumonia today. Then I will, according the habit of this department or some doctor, maybe they will start from Cravit, Curane, or Tazocin. Then I will just give you the suggestion about which the antibiotic is the most frequently used right now and used by department. Yeah, that kind of studies is just like a Google map. Did you use the Google map for driving? That is amazing. That.
Anywhere we can go.
And no, the most amazing thing is they provide you the traffic data.
Yes.
And also which, I mean, for example, I always think that is very useful. Then can be we can learn that kind of experience and apply our method, because in this neighborhood it's very complicated. If you want to travel from Shanghai Hospital to Taipei, for example, the Taipei railway station, is you have a different way to drive from Shanghai Hospital to Taipei railway station. After I spent 3 years in here, then I know in different time I need to utilize a different road. And imagine the Google Drive. The first thing we think about the traditional GPS, they just utilize the shortest distance to calculate which is the shortest way drive from A to B. But the more advanced GPS, sometimes they will consider the speed limit of the road, because sometimes if they just drive the small road, but sometimes they just the speed is just slow. The smarter, some smart GPS, they will give you maybe, for example, you can go this street road but slowly, but you also can go the highway, make a longer distance, but you can avoid the traffic light, that kind of thing. But for the Google Drive, because everyone, if you have a Google phone, they know your speed. So basically, they can use this to monitor all the traffic on the road. And so basically, they have a more advanced information. Besides the distance and the type of road, they also know the current existing the real-time traffic data. So they can estimate the road, estimate the traffic, and give you the shortest way to arrive the destination. But they still have a limitation because they only utilize the distance and the current traffic to give you the best way to arrive. But I'm thinking that I'm not sure Google use it or not. But the Tesla, do you know the Tesla, the auto
car?
Yeah, the auto car. They can that owned by Elon Musk, who created eBay. The Elon Musk, who they develop the Tesla， 就是自动车。对 ，Tesla. Basically, they curate your daily driving is habit. So they know your habit on driving. So they will, according your driving habit, they will optimize the automatic driveway. So okay, back to the previous my question is, from Shanghai Hospital to, because my wife work in the National Taiwan University Hospital, so I need to go to pick her up in the Taipei railway station there. So the GPS, they can the traditional I have the traditional GPS, so they just calculate the shortest distance. They don't care about the traffic. And I like the Google Map because they provide the real-time traffic information, so they can give you the shortest way. And I need to admit that the Google Drive is really amazed me that it's sometimes, even I'm very familiar with the Taipei traffic, after I use the Google Map, I discovered some faster way to drive. Yeah, that's kind of educate me some new knowledge. And I'm thinking that, but you can imagine that all the taxi driver, based on their experience, you can imagine those taxi drivers they should have the most best ability to know the shortest or the fastest way from A to B. So I'm thinking that since the Google they record all people's driving, so basically, so then actually for me they can know every day where I'm going to. For example, I drive from, even I didn't do the Google search, but they can just observe me that okay, in some time I drive from Shanghai Hospital to Taipei railway station. I will use a different route. Then sometime probably they will have some route that will better than the information you utilize the distance and the traffic. Because sometimes just, I don't know, actually I believe sometimes they have some best way to just, for example, that even maybe if you, for example, if we drive from Shanghai Hospital to, here is the perfect example is, if I drive from Shanghai Hospital to NTU, the shortest direction is When I go out from the front door, then I just turn right and go to the Jing'an station. And yeah, but actually, if I go drive in front of Shanghai Hospital, then I make left turn. Actually, that will go a little bit far. That will away from NTU. Then, but after I make a short U-turn, then I can go around the highway, go through the highway. Then I will become more. So in that case, it seems like Google Map, based on their calculation, they cannot know this experience, because I said that the Google Map, even they can they can utilize the distance, they can utilize the traffic, but they have some limitation, because based on their calculation, they don't know, because if I make a left turn, I will go, because if you want to move from A to B, always you need to find a way between A and B, but there's no way say, oh, you can go a little bit far, or you go to C, then you will find a highest way, and then they will make this big. So in that case, but I remember one time the Google suggests me to do that. So if the Tesla, because Tesla will do that, because they will record every day you are driving. So if in that case, if they know sometime, if I make a left turn, then I go a little bit further, but then I can find a better way to do that. The next time he learned the experience, then they will give me the suggestion. Then in that case, I'm thinking then that would be very very cool that you can imagine that in hospital we have the opportunity doing the same thing. Think about the drug. I think there's something related to the TB drug you thinking that is for the traffic, the 2-point distance and the traffic time. That's very easy. We just use the time, the duration from A to B. That is our final. And for the treatment for a patient, I think that is I think that is the goal of the learning hospital. I think nobody said that very clearly, but just we say that because the evolution of medicine is quite slow. When the textbook say, oh, you should try patient like this, then it spend another like 20, 30 years, we just do it. Then only the doctor, they have more experience, then they say, oh, maybe we have some new drug, or like the gastric ulcer. Oh, some people say, oh, that probably is due to a bacterial infection. Then probably we need to treat it. Yeah, always it takes 30, 20 years to have a new division. And the idea of learning hospital is to say that since we have all this information, then actually we can benchmark our treatment real time. Then since we have all the information, so that's always, because I use each time I use the Google Drive, then I'm thinking that it's quite similar that if we can document all those things, actually we have the ability to see that we always can find two patients, their basic condition, they are matchable. Then, and according the different treatment, they derive the different treatment result. So we can have a nice formula or calculator to do that. So always the system can give us, for example, when you prescribe some drug, then no matter maybe for the economic issue or the system, they just give you a suggestion. Do you want to use another antibiotic? For example, the drug resistance rate will reduce to something like that. Yeah, or like before that, do you want to make a the blood pressure control and that kind. But that's kind of too fancy. But I think we always can do that. But the problem is how accurate you can succeed. It's just like a disease prediction model. But before that, I'm thinking because sometimes I'm thinking imagination is very important. So I'm thinking that if we can record each click of the doctor do, then probably we will have the ability to optimize lots of things. For example, we can deal with the usability. For example, I guess there's a pattern when people they make when they prescribing drug, they sometimes they will also click view the laboratory. Then I will, if the system know that, then I just prompt that information to you. It's just like the advertisement that I just give you the information you need. Yeah. So that is something I'm thinking that's pretty cool. We probably can do that. But that is all similar to like classification, prediction, that kind of thing. That's something you can think about that. Okay, then back to our learning project. We have 3 pilot hospitals. So for the Mackay hospital, they 91% can do the learning mapping. And for Shanghai, they have 48. It's kind of low. And Rongzhong, they have 68% can map learning code. Due to some different, it's mostly due to some access problem. But after we use the learning committee, we develop some guideline, then we solve all the problems. So all the mapping rate will become 100%. So that's I say that for almost several years. I want to write this to paper. I think that is a good experience that if people they want to use the learning for mapping, this kind of approach is good. And here is here I give you an example. If we want to do the examination about the influenza A and B antigen, then actually we use a nasal swab to do that. Then we have the nasal pharynx and the nose, and but actually for me, for myself, I believe this is also both are true. I think nasopharynx and the nose are okay. But the historical reason is the learning committee. They at the beginning is they receive all the proposal from different hospitals. So in some hospital they just submit from nasopharynx, and one just from the nose. Both are okay, but we found that that is a common problem. But in learning manual, they have a recommendation. They suggest in this influenza, using the system for nasopharynx is better. So in this case, we during our pilot study, we discovered tons of this kind of mapping. You can consider it's an error or it's kind of confused between the hospital. So after we discovered those things, then we make a conclusion in our mapping committee. So we put that in a mapping guideline because every hospital they need to map this. then we just tell them use the first one. So that is lots of problem because people, they won't confuse about which one is better. We just say, okay, we know that is a problem, just choose the number one, and the following is our reason. Okay. So here is some tell you some result about the inconsistency between the hospital. So it's about 20%. They have some problem. So here is the total distribution. We can see that for the for the the virus is the most complicated, and also pneumonia. They have a more different lowering code. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think here is 15. So you can see all the here we list the 20 is I think the original is 15. Then we increase to 20. So here is the histogram for 15 reported disease. You can see that for the Streptococcus pneumonia, they have 3 different lowering code for mapping. So that is kind of huge amount that if you want to do the mapping, you need to have both the knowledge of lowering, then you also need to have the knowledge from the laboratory. Okay, so that's probably give you a roughly idea. You can, because if you are not entering this study, you will imagine that it's not big deal. You only deal with 15 disease. You just report it to CDC, and that's fine. But actually, you can imagine that here there's still, I think it's more than 1,000. Even after we remove those not frequent use one, but they still have more than 1,000 lowering code. That you need to know which one is the best one for mapping. Then also, this is the very important. All the time, I always use this graph to persuade people that you cannot just create the vocabulary and ask hospital to use it. We need to evaluate and give them some feedback, because sometimes just the problem of lowering, and sometimes just some practical issue. So we need to provide a guideline. And yeah, and imagine each year the CDC for this project, each year is 20 hospitals. They spend 20 million NT dollar for the project, but this only for the mapping. For the infrastructure, they spend another 10 million, about half. They has a company. They maintain the infrastructure. You go back to see this, the gateway.
So it's for this year or next year project. CDC law. You're talking.
Oh no, we finished.
Oh.
But I'm saying that there are 2 main parts.
Yes.
We only helping do the mapping, but they still need to develop a system and talk to the CDC gateway. Then they need some, need a computer. They're still having some, because after mapping, when they having this kind of reported laboratory, they need to submit to the gateway. So they need another set of work. So there's another company. They need to deal with, they need to talk to all the hospitals. They need to bridge their list system and to the CDC. So it's about half amount of money. The 20 hospital, they around use, I think it's 20 million. I think it's more. around 20 million or like 30 million, that kind of NT dollar. But for the gateway, for the infrastructure, they spend another 10 million for each year, and they spend 3 years. They just do this, but it's kind of success. They are satisfied because we solve the most difficult part for the mapping, so they really can. They don't need to deal with the variety of the lab, so they can really observe. Let me show you that. I think they has. I think they work with the Seneca. Yeah, I think they cooperate with. They have. They build up a. Because they outsourcing, I mean, they output this data, the real-time monitor data to Seneca. So they provide a GIS map on that. So let me, I'm not sure I can find it.
So national standard already established from Taiwan for Loin.
Sorry?
National standard for Loin,
yeah,
is developed in Taiwan fully. The standard,
the
national
Loin?
Standard, yeah. National standard, because country to country it varies the terminology or same.
No, Loin is developed from US.
Yeah, US. But is there any difference from country to country?
Slightly. No, not. They have some regional issue.
Like some special code, like extra code or this like.
Usually, very few.
Very
No,
few.
no, yeah, but 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 I have to say that our list system is better than US one, because in Taiwan just too busy, too many patients in hospital. There is no way without a computer.
Yes.
But for US, it's kind of everything development is kind of expensive. So
expensive, yes.
their system is kind of if they need to create a system, their budget may be 10 or 30 times more. So their progress is a little bit behind us. But if they decided to do, they always the best. Yeah. So that's the. Okay. Yeah. Yeah, you can see that they cooperate. I think tuberculosis in Taiwan is kind of. Oh. 0. Strange. Oh, okay. HIV. And, yeah, mostly very. I think the HIV is more prevalent. So you can see, because the HIV is also a reported disease. So you can see the distribution according to, and yeah, show the time trend. Yeah, this is pneumonia streptococcus. And I remember 3-year project. We probably cover, because all the medical center is participated this project. So we do an estimation. Probably more than 60% of laboratory information were monitored in this project. So that's kind of, I mean, especially all the geography, the north, the south, the east, and the west, and most hospitals were covered. So that's a kind of successful project. Yeah, but you can see that we just deal with one tiny thing. We just deal with the semantic interpretability. So you can see all that, but that is a bottleneck for when you want to collect data for study. Okay. Yeah. So here today, give you an idea about what does the really meaning for the interoperability, and I show you a real example about how using a standardized terminology and how we collect the practical usage and how we improve it, and that is kind of useful. You can also think about yeah, I think if you are interested, the ICD 910 is always, if I'm thinking, yeah, I mean, running a company for coding is also my kind of one option, because the Zhiyang, actually he is my surrogate for long mapping. His personality is good for I mean, collecting data, analyze. Yeah, so it's quite amazing that he is a statistical background person, and he have no idea about the clinical thing. But I trained him. I trained him the knowledge about the LOINC, and they also know the knowledge about the infectious disease. Then right now he is an expert about because this area is very focused. Then every year he review a lot of mapping. So he's kind of the CDC. Only the first year we have lots of conversation. I need to teach him. Then right now he is an expert about this. So each hospital currently very few questions will pass to us, because the CDC I mean we almost already collected all the info, all the problem. Then we also know how to deal with that. So yeah, we have the experience about the LOINC. So I'm thinking that for the ICT, yeah, that is also a probably thing. Like for example, I can talk to each hospital and I say, oh, for your department, I can help you to, but not the whole hospital. Or for example, okay, for the neurosurgery, I can help you to provide all the mapping, no matter including the daily practice and maybe the OPD and the inpatient. That is very useful because in the future they need to, I mean, even for this hospital, I think you all know that our TMU, we have a center for they are trying to do the NHIRDB thing. They collect all the data from 3 hospitals. They try to do the same thing. The first thing they need to solve is the semantic interoperability, because the 3 hospitals, they have a different laboratory name, they have a different ICD name. Yeah, if one doctor they say, oh, I want to collect all the patients who has the low back pain, or the more professional term is the spondylolisthesis patient. They need to have a vocabulary server. They need to have a vocabulary to collect all. I guess no one without this kind of training, they don't know how to do that. So even I think this should off record. Even Jack, he didn't know how to do that, right? 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 哎，是。